Welcome back to another YouTube video, guys. Today we will be doing paper 2, further maths, calculator 2024, leaked paper. Let's see how it goes. Is it still kind of leaked? I feel like, yeah, I know it's leaked. You can't get this online.
I thought the mark schemes aren't out, but then papers are out. And
Right.
mark schemes put it on TikTok.
Here we go.
Yeah.
Ready for this?
Yes.
So, first one, straight line part of -1, -1, that's raised 3, 2. I suppose one way we could do this is we could actually plot the point -1, -1, and then just do a gradient of 3/2 gradually, which is doable, or find out the actual equation of the graph of the line. So that way, go that way then. Okay. So we obviously know because it's got a gradient of 3/2, it's going to be y equals 3/2x plus c. We can put -1 and -1 in, which gives us that, which means c is a half. So it's y equals 3/2x plus a half. So you've got to draw it from -3 to 3, so you've got to make sure it goes all the way down to -3 and 3 on the x. Just pick some points. Because we've got 3/2 here, it's advisable to pick some numbers and divide by 2 nicely. Although, actually, because you've got the plus half, that's then going to give you kind of half, so maybe that's not the wisest thing. Well, obviously, if we pick x is 0, y would have to equal half. Yeah. Let's pick x is 1, so then y will equal 2, so that's a nice point to plot, 1, 2. And then when x is 3, y is going to equal 5. It's a calculator paper, so it's, not a difficulty. And just to make sure that we haven't made a mistake, let's put in -1. And, we know it goes from -1, -1. And then draw the straight line through.
It goes to minus. Oh, yeah.
That's really badly drawn, but
Does it have to stop at -3 on that?
It doesn't have to stop at it, but it has to go at least to it. So and this is the same for GCSE, wherever it says from to, you've got to make sure the line extends out to that point at least. All good?
Yeah.
Onwards. I'm going to do this. That's not it, but never mind. I can stand up. Yes, I can. Yes, I have remembered how to do it. Right, question 2 and 3. Oh.
I hope so.
Work out what the possible integer values of n. So, possibly we could do a kind of quadratic inequality on this one, where you just go, right, well, let's take that over there, so we get 5n squared is less than 36. Divide by 5, so you get n squared is less than 36 over 5. Doesn't that mean that the critical value is when we square root that, which is 6 over root 5, which is critical values? I mean, I can say n equals that. Now, are we happy that it's going to be plus or minus? Is your critical values? Because obviously when we square root. So, if you imagine a graph of this, it's a quadratic that's going through at 6 over 5 and minus 6 over root 5 and minus 6 over root 5. Blech, not very nice. And we want less than, so what don't we want between them?
Yes.
So we want all this business here, all this bit of the graph here. So we're going to have x is between -6 over root 5 and 6 over root 5. And because you have the joys of a calculator on this, you could just work out what they are as decimals and then work out the integers in between. What many prices is about -2 point something.
Yeah.
-2 point.
Ish.
-2 point.
6-ish.
6-ish.
Yeah. Because we just want the integer values, it says.
I see.
So integer values there is going to be -2, -1, 0, 1, and 2.
There we go.
I mean, that could be a GCSE paper. But you would now. Right. Rate of change.
dy by dx.
We're going to differentiate, yes. So we're going to differentiate here. And we know that the rate of change is 23 when x is 2. Why did they give us the answer R? Because we have something in the equation we don't know, the k. And that's what we're trying to find, the k. So rate of differentiate. So we're going to differentiate 4x cubed minus 6kx. Lovely. And then we can substitute x equals 2 in, and we know it's going to equal 23. So 4 times 2 cubed minus 6 times k times 2 equals 23. So what's that? 32 minus 12k equals 23, which means 12k is going to be 9. So k is 9 over 12, so 3/4. 8 times 4 is 32, not 28. Okay. You did 4 times. No, you didn't. What did you do? Just gave up on your 4 times table.
Yeah. It's a calculated paper as well.
It doesn't matter. Right, am I okay? Move on. Question 4. Let's see what that's like. Oh, here we go. Here is some information about the linear sequences. A and C, nth term C, nth term A, nth term B. Is that the nth term C? Is that? First 4 terms of B are that. Work out the 20th. Right, okay. So, seems like a lot of information, but actually, they tell us the nth term of C. So we know that is 42 minus 3n. The nth term of A, we need to find that. So should we call that? Should we call it an plus b? Yeah? A general nth term of a linear sequence. We know they're linear, so we know it's going to not be any fancy things with n squareds or anything. And the nth term of b, well, we can tell that straight away. It's going up in 8s. 8n plus 6. Happy with that? That over there. So don't forget that an plus b, our nth term of a, is 36 minus 11n. Happy with that? And therefore we want the 20th term, so therefore 20th term is going to be 36 minus 20 times 11. 220, so that's minus 186?
Yes.
No,
184.
4 minus 184.
Sorry.
Ooh. Sorry. Calculator people. All good? So far, not bad, eh? Confidence levels going up. He says. What's he doing? Get it.
Oh.
Can I just move now?
Oh, see if I can do this.
So, it's refusing to move up, that's what I wanted. I'm obviously doing this in a really stupid way. There must be a really clever way, not clever, but simple way of just moving it up a page. Anyway. Right, working up values in D, so I'm just going to multiply these matrices together and do a little bit of sorting out. Looking at this, we don't have to multiply the whole thing out. We could just go, that first row against that first column has to give us the minus 5. Remember? Row against column, and then once you run out, you go down to the next row against column, row against, yeah? So we could just do that C1 Ah! No, stop. Ah, go away. Right, how do I get rid of that? Yeah, like that.
Yeah.
Right, so C1 against minus 2, 7. So C against minus 2 is minus 2C. 1 against 7 is 7. That apparently equals minus 5. So that leads to C is 6. Lovely. Right, and shall we do... Oh, shall I do a different colour? That row against that. Well, let's do the last one, shall we? We know it will have to equal 9. Yeah? So, oh no, that's a stupid one, because it's 0. Yeah. 2 against someone. Sorry. Is equal to 0.
Yeah.
So, minus 10D plus 21 equals 0. So D is 2.1. That's lovely, wasn't it? Please. Right. See this bit here? So we've got a matrix. We're timesing it by m. Oh, we get the same matrix again. It's like the equivalent of timesing by 1. And the matrix that's equivalent to timesing by 1 in matrices world.
Identity matrix.
The identity matrix 1, 0, 0, 1, yes. There we go. Lovely. So the identity matrix basically is the equivalent of timesing by 1 in the matrix multiplication. So part C. No? 1 to 6 already? Can I move? It must be better, I think. It is. Oh, no. Yes. Still has that. I'm pleased.
The first part the same.
Right. So, function f is given by f of x is 3x squared with domain. So domain, remember, is all the numbers that you can put into the function. Range is all the numbers that come out of the function. Oh, work out the range of the function. Got to be a little bit careful here. So usually we look at the two ends of the domains. So we're going to try minus 1, we're going to try 4. You're going to have to be a little bit careful with this because it's an x squared. But if we were drawing a 3x squared plus 2, wouldn't it look something like that? So actually, that might be our minimum. If the minimum, if you like, is within that function, then we're going to have to look for that as our minimum. So I'm tempted to actually work out what my minimum value is first, by just a couple of ways in which we can do that. We can either think about the graph there, and just go, where does that dip down? Where's the lowest point on it? Can you see that straight away?
X is 0.
So when x is 0, you get 2. Yeah? So when x is 0, that's actually the smallest value that can take, isn't it? Because you've got a squared term. So if it was a minus number in there, when you square it, that turns into a positive, so you get a bigger number.
Oh, yeah.
So actually, x being 0 is the lowest. Now, if we hadn't spotted that, we could just think about the graph and find the minimum point, or, do you remember how we find minimum points, either complete the square or dy by dx? So if I differentiated that, wouldn't it be just 6x? And aren't all the minimum points happen when the different dy by dx is 0? So you'd want 6x to equal 0. Oh, so it's when x is 0 is where the minimum point is. Is one way. You could complete the square, well it's kind of already in completing the square mode, because we've got a square term, yeah. So, anyway, so actually f of 0 in there gives us 2. That's going to be our minimum point. So the function is going from 2 is its minimum point. Yeah.
So basically, I have to select the number, just put 0. Because
It depends if this is, only this is a square term.
Yeah, but
Because if this was 3x squared plus 2x, that's 2, then you couldn't be convinced that 0 is going to be the minimum. You'd have to go, oh, where's this minimum point here? Yeah? So, yeah, you've got to be a little bit careful. So, you know, if this was f of x equals, let's just change it slightly, that, the minimum point's not at 0 anymore. Actually, when I differentiate that, don't I get 6x plus 2? So the minimum point is when that is equal to 0, because all minimum points have a gradient of 0, don't they? And so for that gradient to be 0, would that occur when x is minus a third? Minus 2 divided by 6? So actually that would be the value we'd have to put in to get the minimum. So you've got to kind of think, right, it's not necessarily the two ends, it might be in between that the minimum point's at. And if it's quadratic, you're going to have to kind of go, oh, where's that minimum point? No?
Is that the same for the max? Is that what it is?
Yes, same for the maximum, yeah. Well, no, for the maximum, because it's quadratic, we know there isn't any maximum in it. If it was a minus x squared, then yes, we're going to have to think about that. So the maximum point, the highest point, well, if we put minus 1 in, I mean, it's a bit pointless to put a minus 1 in, because I know it's not going to be the maximum point, but I'll do it. I'll put minus 1 in there, don't I get 5? And if I put 4 in there, don't I get 50? So that's my maximum, 50. So the range goes from 2 to 50. Okay. That's incomplete in the square form, isn't it? So straight away, circle coordinates point where the curve crosses the y-axis. Y-axis is the y-intercept, isn't it? And isn't the y-intercept occur when x equals 0? So if I put 0 in there, don't know what I'm about the x again. So if I replace that with 0, we're going to have minus 3 squared is 9. So wouldn't it be at minus 5? Yeah? So y-axis where x equals 0, so you just put x equals 0 in there. And that occurs at minus 5, so it's that one there.
Was this on mock paper? It looks familiar.
no, mock paper was like 2 papers mashed together.
Yeah, so I might have used a
I
couple of
think
these
so,
questions.
I think we've done this in the lesson before because I remember that.
I think I got this wrong in
He
the
told us
mock.
to do it because we haven't done it.
Yeah, he said just write that word
Yeah.
with questions.
Now then, work out the coordinates of the maximum point of the curve. We could multiply this out, differentiate it, make it equal to 0, find the maximum point. But of course, there's no need to do that because it's incomplete in the square form. So isn't the maximum point going to be when that bracket is 0, which is when x is 3? And when that bracket is 0, isn't the whole thing just going to be worth 4? So the maximum point is going to be at 3, 4, which is to complete in the square. Do you remember with complete the square, you say, right, what value of x makes the bracket 0? And then when that's 0,
Yeah.
yeah.
Wait, does the minus the equation not change anything? No, it's 4 minus, and usually
It does, because what you're therefore finding is the maximum point rather than the minimum point.
Oh, so if it's after,
If it's
then
minus x squared, you're finding the maximum point.
Oh, that makes sense.
Okay,
Oh, I hate
right.
I can make it not a fraction. Oh, why don't I just make it in the decimal?
What we got? Oh, we have to do second differential. That's okay, isn't it? So, I would rewrite this in powers. So, first of all, half x squared, well, that's good. But this is going to be now 3/4 x to the minus 4. Is that okay? Can you see why it's 3/4? A lot of people mess up with the 3/4 bit. So when we all okay with that?
Yes.
So when we differentiate that, aren't we going to get, that comes down the front, so aren't we just going to get x? 2 times a half is 1, and then that comes power 1. And then here, the minus 4 is going to come down. Minus 4 times 3/4 is minus 3. And it's going to be x to the minus 5. Take 1 off the power. You know, luckily you've got calculators on this paper. So you could have just done 3/4 times minus 4 just in case you didn't realise that was minus 3.
But why is it 3/4 x to the minus 4?
Right, because, think of this, if I said 3/4 times 1 over x to the 4, and I said, oh, make that one fraction, wouldn't you do 3 times 1 is 3, 4 times x to the 4 is 4 over x to the 4. So it's 3/4 times 1 over x to the 4. And 1 over x to the 4 is x to the minus 4, so it's 3/4 times x to the minus 4. That makes sense? Yeah, but I know that they put that form just to confuse you. You might, I don't know, some of you might put 12 x to the minus 4, because you go, oh, it's 3, but then I've got 4x to the minus 4, or something like that. I don't know what you do. But you'd be wrong to, whatever you do. It's just that. So second differential, we just got to differentiate again. So differentiate again. We get 1 plus 15, x to the minus 6. Minus 5 comes down there, 2 minuses making a plus, 3 and 5 make 15, take 1 off the power, done. Need it in that form? Yes, we've got it in that form, where a, b and n are integers, yeah. We can have obviously negative integers, that's fine. Right, a set of 4 digit integers each have a first digit greater than 6 and a second digit less than 8. What is the greatest possible number of integers in the set that are multiples of 5? So I always tend to say, right, look, it's a 4 digit integer. So it's going to have 4 digits like that. Let's think about what we can have here. So a first digit greater than 6 means we've only got 7, 8 and 9 that we can have. So we've got 3 choices for that one. Yeah? A second digit less than 8, well that's 0 up to 7, so there's actually 8 of them. No restriction on the third digit. Well, I'll tell you what, probably I would be thinking about multiples of 5, so it's got to end in 0 or 5. So I've got 2 choices there. But then I have 10 choices for the third digit because I've got no restrictions. 0 to 9 could be. So it's 3 times 8 times 10 times 2, which is 480.
I messed up the middle numbers.
Is that okay?
Yeah, not product of
You're right.
This is product of counting. Yeah. So again, this is something that could turn up in GCSE.
I don't understand because I always get like the ends and then, but when it's the middle, I don't understand how you like not.
Well, you're happy with where I got 8 because the second digit less than 8.
Yeah.
And then there's no restriction on anything for the third digit. I could have anything.
But I thought like you'd have to like minus.
This one.
That's only if it says you've got the numbers 0 to 9, they can only be used once. Here there's no restriction like that. You write other ones. If it was one of those,
Yeah.
you're in a bit of trouble to be honest. Because you
Yeah,
would go,
because you have to write down all the
because
different.
you'd have to split it into different situations.
Yeah, we
You'd
did
have
practice
to-
one, it was really hard.
Yeah.
Yeah, I tried to do it and I had to get my sister to do it and she's in university, she couldn't do it. She's getting it wrong.
So you've got different situations really. You could either think, right, let's say there's a 0 there. So the zero's out of it now. Okay? So, if it's got to be a second digit less than, the first digit's got to be greater than 6, it could be 7, 8, or 9, couldn't it?
Yeah.
Okay? So I've got 3 choices for that one. 7, 8, or 9 is there. Okay? I've also got a second digit less than 8. Well, if it's less than 8, it could have been the 7.
Yeah.
So we've got to now split it into, let's say it was a 7 there. So I've only got one choice. I need to work that out. So let's say it is the 7, it's there. So now I've only got second digit less than 8. I've got 6, 5, 4, 3, 2, and 1. Not 0, because I've used 0 up there. Yeah. So now I've just got, what did I say? 6 down to 1. So that's 6. So I've got 6 choices for there. So I've got 1 choice there, 1 choice there, 6 choices there. So I've used up 3 numbers. So I've actually only got 7 digits left for the other ones that I can choose from. So 1 times 6 times 7 times 1, there are 42 ways of doing 7 there and 0 there. If I change that to a 5, well, there will also be 42 ways, basically, because I've not really taken anything away there. Yeah? And then you go, well, what if that isn't a 7? What if it's an 8 or a 9 there? So I've got 2 choices now there. Now I've got a 7 that I could use here, so instead of 6 choices, I've got 7 choices. Oh no, I've used up a 5, thank you. Oh, good. I've used up a 5, so actually I've still only got 6 choices. And then I've got 7 again there. So 2 times 6, that's 84. So 84, 42 and 42 all added together will give me my total number there. I've only got those digits.
Is there not another 84? Because if you have 0 at the end and there's 8 or 9 at the start.
Yes, there is. So that's another 84, isn't it? That's another 84.
252.
See, I'm going to go on. Yeah, 252.
This is a tricky one, my friends.
That's what we made up, isn't it?
Right, let's hope not many people view that. Right, anyway, it's one we made up, but this one's not nicer. Okay, let's go to next. Ooh, let's move this down there. Right, so f is a cubic function, so it's x cubed. The curve OX has a minimum point at A and a maximum point at 1B. Tick one box for each statement. The tangent to the curve at 1B, which we know is the maximum point, is parallel to the x-axis.
True.
True, yeah. Because we know,
Station.
it's like that,
I
isn't it?
remember
Because it's a maximum.
those 2 things.
There are 3 different values of x for which y equals 0.
Yeah, we had it there.
False.
False. There's only 2, isn't there? 1, 2. The function is increasing for x is between 0 and 1. X is 0 to 1. Is it going up?
Yeah.
True.
The second one, why are there only 2 values? What are 2 values?
A and that one there. Because isn't that where y equals 0 is where it cuts through the x-axis? Now usually with a cubic there's 3 because you get this going on and you get 3 points. But there's only 2 because it sits on there. You're only creating 2, so you get what we call a double root. So yeah.
Wait, how did you do the last one?
So if it's increasing, that means it's just going up. Well, between 0 and 1, there's x is 0, there's x is 1.
Oh, it's
It's going up. Now, if you didn't have the graph, a way of finding out if something's increasing is if it's going up, isn't the gradient positive? So if it's increasing, dy by dx will be greater than 0. If it's decreasing, dy by dx will be less than 0. Okay? You right for me to move on?
Did you do that?
Right. 28 pages, man.
I got this
Nine. Whew. How many questions are there in total?
22 or something?
Oh, right.
Yeah,
So we're
22.
halfway on the question. But
Oh, yeah.
we'll probably do some quick ones to start. Triangle ACD. So we're trying to work out this triangle here. So you kind of automatically think, there's going to be some kind of trig in it.
Yeah.
Probably sine and cosine rule. So we're looking after that triangle there. If we want the area, we usually use a half AB sine C. We've got one length, we've got an angle. If we can find that length, we're in business. And we can find that length because isn't it sine rule?
Yeah.
Can we skip that?
There you go.
Know how to do that?
Yeah.
Yeah. Okay. So we just do sine rule. 18 over sine 60 equals x over sine 59, and then half AB sine C for that.
Would you leave it? Wait, how many sig figs would you give it to?
What does it say on the front usually? It's sometimes gives you some. Where is it there? Does it give you any guidance on that?
I can't see it.
It has an asterisk for any degree of accuracy, so I'll just go. There's 2 significant figures given in the question, so at least 2, maybe 3. I would go 3 significant figures personally.
Okay. If you give it to loads of sig figs, does it matter?
No.
Okay.
Yeah, I always do that.
Yeah.
Just to make sure, like 5 decimal
Yeah, like
places.
it doesn't say.
Above it, I write the whole thing out and then it.
Yeah, me too. Like,
Right.
not everything my calculator says.
Hello. Okay.
How's history?
Oh my gosh, it actually wasn't that bad. Like, it's always really nice.
I've recorded so far. We're just doing the paper 2. I did some paper 1 on Thursday, but we went through that.
We're on questions as well, but email Morris not.
There's still no crossover topics of that. Right. Oh, it's a circle question. That would be quite nice.
Oh, I love circles. Oh my gosh, there's so many people! Wow!
Hello, hello.
Yo!
Do you want to
How was it?
Paper 2.
I put it on here this people because I had to.
Are you talking about the tone of
Yeah, I
the
did. I did.
of the image?
It was so jazzing.
We're filming. That's fine.
Oh, do you guys like
I might.
I thought it was so
so
bad.
Okay, bye.
Why?
See you tomorrow.
I'm recording it, yeah.
Yeah, the screen recording of the
We're filming it. I don't think many people
vlog.
probably not many people have seen it.
Right. Let's crack on then. So, question 12. We've got a circle. Equation of the line is y equals 4 minus x. The circle and line intersect 2 points A and B. Show that the x coordinates of A and B satisfy that. So, this is basically simultaneous equations. So we're going to substitute y equals 4 minus x into there. So we're going to simply do x minus 2 squared plus, and instead of writing y, we're going to write 4 minus x plus 3. It's to show that, to do actually do these steps. Okay? And then we're going to expand that out, and hopefully it's going to look like that. So expand the x minus 2 squared out, you get x squared minus 4x plus 4. This is now 7 minus x, isn't it? Equals 16, 4 and 3. So expanding that out, you get 49 minus 14x plus x squared. equals 16. Have you got the paper 2 already?
Yeah.
So, just simplifying things. Boom, boom. 2x squared minus 18x plus 53 equals 16. 16 over there. Oh, lovely. We've got our answer.
So if you leave it as that, has it shown that it satisfies it?
Yeah,
Yeah, I'm using brains.
because you're basically showing that the solution to this simultaneous equation, we just eradicated the y, so that just leaves us the x, does actually give us that equation. And I'm going to guess that they're probably going to ask us to solve that.
Probably.
So are we all okay with that?
Yes.
So, for A, the x coordinate and y coordinate are both positive. Work out the coordinates of A, given each coordinate 2 decimal places. 2 decimal places should be flagging up to you, oh, I've got to solve a quadratic. 2 decimal places, this isn't going to factorise. So we're going to have to use the quadratic formula. And I've forgotten already what it was. Not the quadratic formula, obviously.
Yeah,
but
obviously.
2x squared minus 18.
2x squared minus 18x
Plus 37.
plus 37.
Oh, it's in chronological order.
The quadratic formula is on your exam aid. You don't even have to memorise it. But we've got an A of 2, haven't we? A B of minus 18 and a C of 37. We just put everything in. Be careful of the minuses in the discriminant, the b squared minus 4ac. Don't forget it's all over 4 this time, because 2a is over 4. Plug it all in, get your 2x values. And then don't forget your y values. Go back to the original 2 equations. Pick the easy one, which is y equals 4 minus x, yep. And just plug them in. Okay. Have we actually done it already?
Wait, because it says decimals, do you know that you can't do the wiggle?
Yeah.
That's okay.
Yeah. That is a big, big telltale sign that factorising is not the way to go.
Okay, that's fine.
Or the wiggle method. Although who would use that?
It's actually a well-renowned method.
Thank you very
I
much.
use it all the time. It's like the only way I can do it.
Yeah, that's the only one that makes
If it
sense.
works
It's
for you,
trial
that's
and
fine.
error.
Wait,
like-
If it works,
I can get the other one.
Set Warner doing the wiggle method. Set Warner.
Ooh.
Disgusting.
I mean, let me down really, don't mind. Oh, we want them both positive, don't we?
Yeah.
So we're just taking the positive x and the positive.
Both of them are positive, so you take the smaller one, which is less than 4, and put it in the easy one.
So because we've got y equals 4 minus x, we're going to take the x that's less than 4 to give you the y coordinate as
Yeah.
positive. Okay. What's the final answer?
I got 3.18 for x and 0.82 for y.
Sounds good to me. That does sound familiar, that question. Not done it? No?
Maybe it's because past being.
Are we okay to move on?
Wait, how did you find out the Y one?
Because
put it
y
into-
equals 4 minus x?
From the
Well,
original.
because they say they're both positive, you have to obviously work out the one which gives you the positive y as well.
Wait, which one, where did you get that from? The,
That's part of the question. Right.
oh, that was it, oh, okay.
Yes? I click off?
Yeah.
Right.
Oh, what was the y coordinate?
0.82.
Oh, can we skip that?
Why?
Just triple bracket. Multiply that triple bracket.
It's
Wait,
very
you were
important.
struggling with it.
This used to be one in every single maths paper.
Have
You
we
had
already
in
had
paper
one?
2, didn't
Have
you?
we? Yeah.
I think we had one in paper 1 as well.
Is it paper 1 and paper 2?
I feel like
I
there
don't
was one on both.
I think
But
it
it was compound
It's paper
fractions on paper one.
No, paper 2 you had one.
Yeah.
I was mixing it up with the compound
Oh,
fractions.
Mr. Norris, on paper 2, there was kind of a vectors question where you had to shift the circle down. So does that mean there's going to be any vectors on paper 3?
I think it's still be vectors.
Yeah, because that's not a vector.
It's
Yeah.
technically a vector.
If anything, it's a translation graph question,
Okay.
but
Also,
pretty lame one.
what was the answer to the like dollar and capital?
So there's 27,000 something.
Yeah, 27.
Oh my god. It was just stupid.
There were so many people arguing on TikTok.
15 times 14 times
Yeah.
12 times 11.
Yeah.
How do you not get that? You get the full 3 marks if you add them instead. Like times times
No,
times.
no, no.
Yeah.
If you did 15 times 14 anyway, you're going to get a mark.
So many people added it.
Please,
Right. Ready for next bit? Yeah, we're going to skip that. Come on. Come on, we can't skip that.
Yeah.
You can't do it.
Triple brackets. Yeah, we're skipping that. Okay. Here's the point on the graph, y equals 3 minus x. That has x coordinate minus 2. Here's the point on that graph. Y coordinate p equals y coordinate of q. Work out the x coordinate of q. Right, let's say that again. The y coordinate of p. So the y coordinate of p. Oops. So the y coordinate of p, it says up here, p is the point on the graph where the x coordinate is minus 2. So we're going to have to put minus 2 in there to get what y is. So y equals 3 to the minus minus 2,
So it's just 9.
which is just 9, yes. So y equals 9. So we know the y coordinate of p is 9. And that's going to equal the y coordinate of q. So that means we come to here and replace the y with a 9. So we're going to solve 9 equals 1152 times a half to the x.
Yeah, you've got the same.
So we do 9 over 1152, which thankfully cancels. Does it not?
Yeah.
And it cancels down to
1 over
Oh, wait, 1 over 128.
1 over 128. Thank you. So doesn't that mean that 2 to the x is 128?
Yeah.
So how are you with your powers of 2?
7.
7, yes. And you can obviously just get your calculator out and check that. Or just go up in 2s. 2 times 2 is 4 times 2 is 82. So on.
I'm not doing all that.
Or you could go 2 to the 3 is 8, so 8 squared is 64, so that's 6 so far.
Yeah. How is it not minus 7? Because aren't you like flipping it? Like the 2? Oh no, it's a half, never mind. Sorry.
Yeah.
Yeah.
Yeah. Otherwise you would be right, yeah.
Okay.
It's a
Yeah,
half.
but suddenly you went for it.
Wow. What a friend.
Rhiannon, you're so nice.
We're going for the next one.
Just want to use the wiggle method, I see. That was not what I wanted to do.
I think you should try solve it upside down.
That's a good idea.
What's it now doing? Right, so back to where it is. Yeah. Right. Yes. Wiggle. So, as with all algebraic fractions, factorise everything you possibly can, and then go from there. So, shall I just leave you to do that while I do it?
Yes.
Oops. I need a pen. You wiggle away.
Rhiannon, I've forgotten how to do the wiggle method.
This is that's the point.
You might want to learn that.
Would you like me to explain explain for you, because obviously it's so clear.
I've got into the times and
You can explain to the camera if you want.
Okay, so hello, Norris Nuts. So I will be explaining the wiggle method today. So the first, the quadratic we will be forming, wiggling, is 2x squared plus 9x minus 18. So with A and B, which is, so you say 2 is A, 9 is B, and minus 18 is C. You need a number that times is to get B, which is 9. Oh no, it's the other way around. Times is to get AC and adds to get B. So let's think about that, shall we? Let's plus 12 minus 3. So then you rewrite the formula, but you put 2x squared normal. But then the number that you've worked out, 12x, you write that there, and then you write minus 3x, and then you write the end of it minus 18. Then you have to factorize this. So it will be, you will factorize the 2x out of the equation, leaving in brackets x plus 6. Then you will repeat that method, factoring out the minus 3 in brackets x plus 6. Now you make 2 brackets, 2x minus 3, and then the one in the bracket x adds 6. And you're done.
From the bottom of the fraction.
Right,
I haven't done the bottom yet.
and there we are. We get x plus 6 over 6x plus 5.
Yeah.
I only did the top.
A little bit of quadratic factoring. I even wrote out some working out for you on the side for the second one.
See, that is trial and error, but this is not.
But how do you get working marks if you just do it like that? Because what if you got it wrong?
Don't you get working marks for
The
factorising it and then
marks are
cancelling
usually
it?
for the factorising, but you can make sign errors here, and you still get the method marks.
Yeah, but what if you're not confident in that, but you tried to do it like that, but then you got it wrong, would you just not get the mark?
You'd still get some marks of like that and that multiplied to make 12, and that multiplied to make 15. That's the usual way they go to give the marks.
I'm just gonna stick to my method.
Right, next,
Wait, like time
15. So did you say there's 22 questions?
Yeah.
We're going to do this. Oh, hello.
We've got this down.
I think that's okay, isn't it?
Yeah. Well, this one's.
So, if we, do you want to do it in powers straight away? Yeah? Okay, so x cubed square root is x to the 3 over 2. And you're going to have x to the 3 over 2 there. And you're going to have just x cubed there. And on the bottom we get x to the half. All happy with that. Now we can multiply, and when we multiply we add the powers. So 3 over 2 plus 3 over 2 is just 3. So that's going to be x to the 3 plus 3 over 2 times 3 over 2 plus 3 is 9 over 2. Some more time on that. All over x to the half. And now we're doing it in two separate fractions. That one and then that one. That really messed up, sorry. So that divided by that, we subtract x to the 2.5, or x to the 5 over 2, I'm looking at it as, plus that, subtract that is x to the 4. And that's the form they wanted in. So right, happy with that?
This time next week we'll have finished all of our GCSEs. Yeah, it's Wednesday.
Is it? No, it's Tuesday.
Wait, this week plus a day.
Okay.
No, we're all finished all our GCSEs. This is level 2 second.
Also, Aunt Lydia finishes tomorrow.
No way.
No, I
Yeah,
know.
she is a spider, so she doesn't have...
Wait, really?
Yeah. Yeah, her last
Guys, I should have done more science.
I've only got 6 left now.
Same.
I've got
7.
7.
How have you got that many? I did music, but like, what's your
Yeah, I've got 7.
Geography?
Geography.
yeah.
Right.
We've got Spanish.
7.
Okay. With this one, work out the size of the angle between the slant and height of the base. So basically saying work out that angle there. And you've got a lovely little right angle triangle here, haven't we? 7, H and L. So really we just need to work out either H or L would be lovely. Probably the way to go is the fact that pi r L is the curved surface area, and we know the total surface area of the cone is 224 pi. Now total will include the base. Just got to be a bit careful there.
Oh, so you add them.
Yeah, so we do pi r L plus the base, which is pi r squared, will equal 224 pi. Notice there's a pi in the answer, so we can just cancel the pi's in a sec. So we know r is 7, L we're trying to find. So 7 pi L plus 49 pi, because r is 7, equals 224 pi. Now, cancel the pi's. Boom, boom, boom. So 7L plus 49 equals 224. Solve that to get L. So that's, there you go, Ruth.
25.
Oh, well in the by the way, I've recorded all the rest of it.
Yeah, I would definitely watch back at the clip.
Okay. Wise advice. So, what we're doing here, 24 there, so 175 divided by 25. That is 25.
Yeah.
And now, if we want the angle, therefore,
Oh, wait, what?
no, not Pythagoras, just trigonometry.
No, I thought we were working out H.
They find out the
Well, no,
angle.
L or H to do. So we've got a right angle triangle. So we've got the adjacent and we've got the hypotenuse. So we're going to use cos. So should we call that x? Cos of x equals 7 over 25. And then you can get your angle.
Did you get
Which
73.74?
is
I did.
73.74.
30,
73.74.
73.74.
74.
That's so close to the answer on the last question on paper 1.
Oh yeah, but that was just 73. Was it round? I
Yeah,
can't
it was,
remember.
no, it was 73.
Yeah, it was wrong.
Was it?
Yeah, it was-
And then I saw afterwards that it was actually 73. I was so proud of myself.
Right, all good?
Yes.
Okay.
Yes.
There's a part B coming up, isn't there? Oh,
How is
hello.
that related?
They're both kind of 3D.
It's not like you take information from questions.
I feel like I've seen this one.
I think some of the questions from this are on a lot, but I don't know which ones.
Okay, so let's see. We've got our lengths there. The acute angle between the planes NNB and
Kyla Reese Lopez.
HDCG is 36. Okay. And then
No, this was on our map,
Was
wasn't
it?
it?
I can't
I
remember.
feel like it was this on our map, and everybody was like really struggling with it.
I can't
that's all you get right. So first thing to realise is what angle they're talking about. So you've got that plane, it's that triangle, and it hits the plane at the back, because
It was similar, but it
HDCG
wasn't this
is
question.
this plane at the back.
It looks the
So
same.
It
actually,
was on a block, I think it was
it's
the
that
middle of the
there.
lesson that no one could figure out which
Oh, yeah,
because
it's
it's like from long
No,
corridor.
Yeah,
it
where
was
the
on
two
the
planes
map.
meet.
But then we did it in the lesson.
Can we spot that?
Yeah, I did. The wording's a
So
bit.
it's that angle in there. So basically you've got N down to C
Yeah, no, but I swear that angle that we were
Down
supposed
to
to work out
B.
was that.
and across, and you've got that is 36 in there. You want what CN is, great. Well, we know that's 25.
Have they just given you MNB as a triangle for no reason?
We did this. This is the one that everybody got really confused on because it was really hard to work out, but then it was actually just a really easy question once you'd worked out what it was asking you.
Yeah.
So all they really see is that you realise that the angle between the two planes is that angle there.
Yeah, because I remember I went to maths clinic with that one, and Mr. Edge couldn't work it out until later.
Oh my god.
He had to send me a message, like say, because he took a picture of it so we could go and work on it because he couldn't get it initially.
Because at first I got confused by the triangle of MMB, and then I realised that's just doesn't matter.
Well, it is because it's the plane.
It's because
Yeah.
it's really hard
So
to
it's
work
where
out
the
what
triangle
the angle is.
hits the thing.
Yeah.
That's the base.
Can we not speak negatively about American
So
stuff?
the
This is really upsetting.
The 16 and
I
50
didn't
are there
say that
because
he didn't reach
this
the
question is about do
conclusion.
you know what they're talking about with that angle? And therefore, if you don't, you're going to use either 16 or 50, and then they know you've done it wrong. So, yeah.
Okay.
So basically, we're just going to do, what do we want on CN?
Yeah.
Tan 36 equals 25 over, call it x again. So x is 25 divided by tan 36. Is that okay?
Yeah.
That's a hard one. Because spotting that three-dimensionally.
Mr. Roberts,
Yeah.
what actually is a plane?
So a plane is like a sheet. So you know, if you've got a cuboid and you've got a face, that face is a plane. So they've got a triangle coming across that whole kind of. If you take a slice, if you like, through that triangle, the face that you're left with, that's a plane. So a plane is like a two-dimensional sheet, if you like, somewhere. So yeah, you've got the back of the cuboid and this triangle coming in here, and it's that angle between these two here, which is going to be the same as that angle down there. Okay. Oh, did we get an answer?
34.4.
30.
4.4.
34.4. Okay. Doing well, folks. That's all right now. You've got a k cubed in there, so we're going to have to do a cube root at the end. So it's just like your normal rearrange, make k cubed the subject, and then cube root at the end. So don't forget to put that over there. So m5m minus 3k cubed equals 2k cubed minus 7. Bit of multiplying out, 5m squared minus 3mk cubed equals 2k cubed minus 7. Should we get all the k cubes on that side? So you've got 2k cubed plus 3mk cubed on that side. And on this side, 5m squared plus 7.
Yeah.
Gives us nice positive numbers then. You could put it on the other side and just have minuses, that's fine. Then we're going to have to factorise the k cubed out. So we're going to be 2 plus 3m. Divide. And finally, let's get that k cube rooted.
Yeah.
So k is going to be cube root. Make sure you write the whole fraction under the cube root sign. They like to penalise if you don't. You've got to show that it's the whole thing that's being cube rooted. Oh. 3 to go, 4 to go?
4.
4 to go. We've got this. I haven't seen a binomial yet.
It's next question.
Oh, is it?
Yeah.
Right. Don't hate the binomial, they're great binomials.
I mean, Rihanna did
Oh.
binomials actually.
Oh, right, this one's wrong. Expansion of 3 plus ax to the
Oh, wait.
5. 8 times the coefficient of x squared
Yeah.
is the coefficient of x4. Work out the possible values of a. So, let's do the we don't have to expand the whole thing out. We could just think about the x squared terms. We can think about the x to the 4 term. So x squared term first. We are just going to get an x squared term, we're obviously going to have that ax being squared. 3. And that means that 3 is going to be raised to the power of 3, because don't these have to add up to 5? Yeah, because we've got to the power of 5. So it's almost like we've got 5 brackets, we've chosen 2 of them to have an ax, and 3 of them to have a 3, that means. Now then, we then have to do the choose. We've got 5 brackets, and we are choosing, and it doesn't matter which one you do here, because you're going to get the same answer. 2 of them to be ax's, but if you put 5 choose 3, that will give you the same answer. Choosing 2 of them to be ax's is the same as choosing 3 of them to be 3's. So it's 5 choose 2. Set 2. You've done combination, you've done C's, 5 choose 2, or did you do Pascal's triangle?
Yeah, we've done that.
You've done that.
What?
How do you do Pascal's triangle if it's like on the non-calc?
Oh, you know, you can add all them. Me and Rihanna found out earlier. You can do like,
Yeah.
adds the 2 above it and then makes the 1
Yeah.
below it.
Oh!
So like,
That's some common knowledge.
Rihanna, you didn't know
So
till
that's,
an hour ago.
so that's the power of 5 one.
I swear.
That's the power of 4 one, that's the power of 3.
I said it, but then you said it was wrong, so I was like, oh.
So
And then
the power of 5 one is this one.
Yeah.
So we've got 5 choose 2, which is 10. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose
It's
4,
just a
5
different way
choose
of
5.
saying it, but it gives you the same value as like the third one.
So it's 10.
It's just a
But
calculator.
they're on your calculator.
Name.
So this is, let's sort this out,
Why do you use
10 times 27 times,
What would I
and be careful here,
Pascal's triangle.
a
So like,
squared
the
x
first
squared,
row,
don't forget it's
the
a
second
squared, because the whole of ax
It's
is
the one
being
with the
squared.
2, the one with the 3, the one with the 3, the one with the 4.
So that is 270.
And you
a
use that
squared
row
x
as
squared.
your first column.
I think doing this one's
We all good for that?
yeah.
What's you're not getting?
Well, I just don't like get like how have you got if I saw that question I wouldn't get the 5 choose.
Do you know where the ax squares? Well,
Yeah, I
chose that.
understand the 3 and the ax, but I don't understand the choose thing or the Pascal's triangle.
Okay, so very simply, let me think. I can't believe I'm doing this 5 brackets, but I will do 5 brackets. There you go, 5 brackets. So each term you get when you expand that out, it's like doing that times that, getting an answer, then times it by that, getting an answer, and so on.
Yeah.
Yeah? You've got 3 plus ax in each bracket. I'm not going to put them all out. And so every term you get is taking one of these terms, say like the 3, times one of these terms, like the 3, times maybe the ax, times the 3. So you take one from each to multiply out and that get you terms. A single term. But you're going to have thousands, not thousands, but a lot of them. Okay? So it's kind of realising, well, if I'm going ax squared, surely I've therefore chosen 2 of the ax's.
Yeah.
So it might be that one times together. But then I'd have to times it by the 3 3's to get ax squared and 3 3's. Okay?
Yeah.
Now this 5 choose 2 is just a way of working out how many ways can I do that? Because I could have chosen ax and ax, then the 3 3's, or I could have chosen 3 3's and then ax, or I could have chosen 3 ax 3 ax 3, and it's all the different ways. Now it's too late to go into how that works, but you can just do it on your calculator. 5 choose 2, I've taken 5 brackets and I'm choosing 2 of them to be ax's. Put that in your calculator to tell you how many different ways there is. Pascal's triangle, can you see how you work out the numbers? Yeah? Go down to the 5th one. 5 choose 0, 5 choose 1, 5 choose 2, I was worth 10. So if you put 5 choose 2 in your calculator, you get 10. So that's how many different ways I can have 3 3's and 2 ax's in all my combinations. So it's 10 ways of doing this. 3 cubed is 27, ax squared is just that. So that is what my x squared coefficient is going to be if I expanded this all out.
Okay.
Now if I'm doing the x to the 4 term, this time I'm going to need ax to the 4, aren't I? Which means I'm only going to be left with 1, 3. And that can be done 5 choose 4 ways, or 5 choose 1 ways. It doesn't matter which one you choose, because they're the same way. Because 5 choose 1 is 5, and 5 choose 4 is also 5. So it's going to be 5 times 3 to the 1, which is 3, times a to the 4, x to the 4. So that's 15, a to the 4, x to the 4. Okay? So, 8 times the coefficient of x squared. Well, the coefficient of x squared is that. So 8 times 270a squared is equal to the coefficient of x4, which is 15a to the 4. So we have ourselves a little equation we can solve. We know a can't be 0. That would be stupid. So we're okay to just divide by a squared both sides. Normally we don't like doing that, because that means we're eliminating the fact that a could actually be 0. But we don't need that, because obviously a... Yeah. So, we're going to divide by a squared. A times 270 is 2,260.
2,160.
Oh, dear me. Equals 15a squared. Divide the 15 in.
It's been a long day.
Yeah, no, it's just so upsetting that. Right, I can do this though.
You got it.
I've got this.
Come
So
on.
14. No, it isn't. 144.
Yeah.
And so therefore A is plus or minus 12.
Can you leave it as plus or minus 12 like so have you?
Yeah, that's right.
Plus or
Yes.
minus what?
12.
12.
What did you ask?
Can you leave it as plus or minus 12? Like instead of writing it.
Right. That was depressing, that one.
Okay.
I couldn't do 8 times 200.
It's period 6.
Yeah.
We all have our days.
Yeah. It just happened a lot nowadays. Right. Happy for me to click off that? Right. Onwards. 20. Ooh. Oh, lovely. Area of triangle AOB. Yeah, we've got this. Right. So, firstly, AOB is a right angle triangle. So surely we just want to know what that height is and what that length is. Times the half it. That height, isn't that where the tangent cuts through the y-axis?
Yeah.
And that length is where the tangent cuts through the x-axis. We find out the equation of that tangent, we're in business. So, do you remember we do gradient of the radius and then negative reciprocal gradient of the tangent? The only thing we get is this centre is not at 0, 0. Where is that centre? 3, 4, yes. X minus 3 squared, y minus 4 squared.
Wait, how do you know the centre's at 3, 4?
Because x minus 3 squared and y minus 4 squared.
You get the equation on the equation sheet.
Equation of the circle is this.
I thought it was x squared plus y squared is r squared.
That's in normal maths.
That's only if it equals the centre's 0, 0.
The centre's at
But
0,
in
0.
this context, it's not.
If the centre is not at 0, if the centre is at AB, that's the equation of your circle.
Can that come up in normal
No,
now?
No.
it's not. We established this last week if you were here.
You get that equation on the further maths sheet though.
Okay. So, would we agree that the gradient here,
Is it
changing
not
y,
just because most of it is just minus?
changing y is 5,
Because the other quadrant.
changing x is 2,
Yeah, but if the centre is
The
in
gradient is
the
pi over
end,
2.
it would just be 0.
Negative reciprocal.
so negative reciprocal is minus 2/5.
Whoa. How have you got into 5/2?
So, changing y has gone from 9 to 4. So that's
Oh, I
fine.
see now.
Changing x.
Okay.
Yeah. So the gradient of the tangent is minus 2/5. We've got a point it goes through, 5, 9. I remember that you lot prefer to do y equals mx plus c and then work out c.
Yeah.
So let's put in 5 and 9 for our y. Oh, that's nice because the 5s will cancel. So we're going to get c equals 11.
Wait, how do the 5s cancel?
Minus 2/5 times 5.
Okay.
And so therefore our equation is y equals minus 2/5 x plus 11. So isn't that 11 up there? Y-intercept.
Oh.
And isn't this down here where y equals 0? So put 0 in there. Minus 2/5 x plus 11. That over there, 55 over 2. Is where B is. So now the area is just 11 times 55 over 2 divided by 2, which is 605 over 4. Is that right?
Oh, fuck.
That is fine.
Can you leave it like that?
Thank God. Yeah, I'm not do anything other than that. That's perfectly fine.
You're correct. Oh, divide by 2, yeah.
Yeah, don't forget to divide by 2 on the triangle.
Yeah, probably.
Whew. 2 to go.
You got this.
Wow, guys.
Right.
If you've made it this far, enter the giveaway now.
Like and subscribe.
Function 1. F to the minus 1 at x plus g at f of x simplifies to that. Work out the values of A, B, and C for 6 marks. Okay, so do you want to do the inverse first?
Why not?
So the f minus 1x here, do you remember you do y equals 2x minus x over 3, make x the subject and then swap it?
I do the other way.
No, you don't.
Like I did x. I'll turn the x into a y.
Oh right, so you do it straight away and then,
Yeah.
yeah, that's okay, you can do that.
Yeah.
So 3y equals 2 minus x, so x equals 2 minus 3y, so f to the minus 1 of x, it's going to be 2 minus 3x.
Yeah.
We haven't. You've lost your skill.
Yeah, I know. What happened?
Now, g f of x, so you basically, g f of x means do f first and then stick it into g. So we're going to do f and get this horrible 2 minus x over 3. And we're going to stick it into g, which is that. Oh my word. 18, 2 minus x over 3 squared, plus 15, 2 minus x over 3. Oh,
It's alright, we'll get
there's
through
some
it.
all right stuff here.
We'll persevere.
So, first thing to spot. Don't bother multiplying this out. Yes.
So I said.
You can divide it all by 3.
Because, well, isn't that 18, 2 minus x squared over 9? Square top and bottom. And so those are going to cancel nicely. Here, the 15 and the 3 cancels nicely. So isn't that just 5 brackets 2 minus x? So we've now got 2 minus x squared, plus 5, 2 minus x. So, 2 minus x all squared is going to be 2 brackets 4 minus 4x plus x squared. And that is, let's go straight to 10 minus 5x. And so the whole thing is going to be 2x squared minus 8x minus 13x, 8 and 18. Add it onto that. So we've got in the end f minus 1x plus g, is it plus? Yeah. Plus gf of x is going to be 2 minus 3x plus this, 2x squared minus 13x plus 18, which is 2x squared minus 16x plus 20.
Yeah. It says to give A, B, and C.
You've got a bit more to do.
You have to leave it. It's like you can't see it on yours, Mr. Norris. It looks like this.
It's fine. You literally just put 2
Oh, you have to put the
minus
numbers
30.
Yeah.
2 minus 16 and 20, yeah. 6, actually, okayish marks.
Yeah. If you stick with it, it'll be
Oh,
fine.
Krisha, you did the wiggle method on that one. That's not right. No, it's not.
Last one?
Wait, who's this?
Yeah.
Why?
Oh, it's
I don't
proof.
I don't understand.
Prove that x equals 90 minus 3
Oh
over
my
2
god, I
y.
got really confused on this. Then I remembered alternate segment
Like
theorem.
theorem.
Yeah.
Yeah, that's not.
Yeah.
Alternate segment.
So,
It is.
I'll quickly look up, because it hasn't said give reasons at every stage.
No, you don't have to.
I don't think you have to give the reasons.
But if
not
it's
really.
approved,
I'll
but
quickly
if
look
it's
up.
approved, then do you not have to
Yeah,
show
that's,
it?
that's what makes me a
Because
little bit.
I'd just show it if it said prove.
So are we happy that this is going to be y as well, from alternate segment?
Yeah.
So angle, what's that, ACB.
How does alternate segment theorem work?
Oh my gosh, I
It's
literally got
like
the same as him.
the angle in the alternate segment is the
Celebrate your wins, Rhiannon. Don't feel pressured into like, you know, sitting back.
Yeah,
Looks
what I
like-
was thinking, I speak out.
Yeah, it's like
What someone's, I'm so tired, don't even know who's asking. Someone's saying, how does alternate segment theory
Yeah.
work?
Yes, one of your set oneers. Set oneers.
Fine, circle,
it's like
tangent to circle. If that tangent hits the radius, we know it's 90 degrees, don't we?
Yeah.
You can ignore me and this is...
See, but I just
I've
got
got
out.
different colours.
Intermediate math challenge icon.
So, if it's a radius, it makes 90 degrees. If it's not a radius, if it's just a chord, it makes an angle here that we can call x. If that chord goes to any other point on this part of the circle, any point, that angle will also be x.
It's because you get the line, you get the chord, and then you bring it together to that one.
So you just move the chord around, and then wherever the chord is like.
Wherever the angle between the chord and the tangent will be the angle created from that chord to any other point.
I'm the stuff.
Oh,
Yeah.
So here, you've got a chord hitting a tangent of
Would
y.
it prove x
Yeah.
equals x?
So that chord then goes over here, so this is y as well.
so the chord.
I learned the alternate segment theorem this morning. It's good.
What did you say?
I learned it this morning.
Oh,
I know,
it's
I
like my
understand it.
deep
Cramming.
memory. 'cause I
Well,
did it
right,
for-
cramming
actually
101.
proved it, and we went through.
Would we agree that this angle here and this angle here are basically 180 minus y half?
Yeah.
Because it's an isosceles
That's
triangle. So
I
we could
agree.
go angle,
I got.
let's call this one here ABC.
Ravi's so good.
Equals
Ravi should be
180
teaching
minus y divided by 2.
I can't hear you.
You'll see. Actually, I think it's fine. I got the one.
Agreed?
Agreed.
And then, can't we just go, I've got a big triangle here. So x, y, and this must equal 180. So x plus y plus this, which we split into 2 bits, so it's a y and it's a 180 minus y over 2. That's meant to be an 8. I mean, what is that? Come on. There we go. 180 minus y over 2. We know it's got to equal 180. Because it's your 3 angles in a triangle, making 180. I don't think you need to write down this 180 degrees in a triangle. You can get away with that, I think. All happy with that? Don't like that too. Although it comes up there, doesn't it? Shall I leave it?
If you want.
Yeah, so let's just divide these by 2. So we're going to have x, we're going to have 2y, 180 divided by 2 is 90, and minus y divided by 2 is just minus a half y.
Oh, right.
So I've done 2 into 180 and 2 into the y. I can now
Yeah,
go,
it's fine.
Wasn't, but there was
Can we get
2y, so if you're timesing it by 2, surely it becomes 4y.
I haven't times by 2, I've just done 2 divided into 180 and 2 divided
Oh,
into
I thought you'd moved up. You
Can I, what?
There's not when you've got a moment, I'll pop ready. I've just got a question for you.
Yeah, sure, yeah. So, got my x, get everything else onto the other side, take 90 over there, you get 90. 2y minus half y is 1.5 y, or 3 over 2y. Over to the other side, minus 3 over 2y. We are all done.
And that's how you get a 9.
Yeah.
What?
That'd be
It's
perfect.
not, like, maths is no, it's not. Yeah, it is.
Right, do you want to stop the recording?
Yeah. Bye, guys.
Let me
Thank you
just go
so
and
much
quickly
for
sort this out.
watching. Next week we will have a giveaway, and Miss Norris will be giving away.
Bye.